Bonjour, Devoxx friends. Now we're recording, so thank you again for being here. We have a full room, so I'm super happy to be talking with you today about revisiting design patterns after 20. And why did I pick 20? You might be wondering, is it Java 20? Yes, but I also tried to make a bad pun about more than 20 years of the original design patterns book. And because English is my second language as well, nobody understood. So that's why I have to explain the pun, which, well, now you understand why it's a bad one. So yes, after Java 20, which was released a few weeks ago, and after more than 20 years of the original book. My name is Edson YANAGA. My email, yanaga@google.com, my Twitter @YANAGA, and I'm a developer relations engineer working for Google Wallet. So in 1994, we had this book released from the Gang of Four. It was very important at the time because it allowed us to create reusable concepts that later were widespread within our industry. And also a good book that presents some patterns is the Domain-Driven Design one. I took at least one from this book as well. And of course, we have the Effective Java book. Even though we didn't present patterns, some of the concepts we were able to reuse practically everywhere in the design patterns that we're going to use today. So Java 20 was released on March 21st, 2023. And what I'd like to share with you is this definition of what is a design pattern. A design pattern is a general, reusable solution to a commonly occurring problem within a given context. And I emphasize these particular words in blue because if you're trying to use a design pattern without a context and within that context with the right problem, then it's a good solution. If you try to use the design pattern without the context or in the wrong context, actually it becomes an anti-pattern. It becomes a bad practice. And given this definition of design pattern, what I want to share with you is that I think that the most important thing for design patterns 20 years later is that design patterns allow us to create what we call a pattern language. 20 or almost 30 years ago, when you wanted to explain a solution to your team, to your colleagues, you would have to explain, well, we want to create a solution where we will be able to vary the implementation based on the type that we're using, and we want to change this particular implementation at runtime. So we don't need to know in advance what is going to be the implementation. Well, you just described the strategy pattern. So 2023, you don't have to waste like 5 minutes explaining what you want to achieve. You just say, we need a strategy pattern. We need a template method. We need a singleton. We need an interpreter. We need a visitor. So design patterns allow us to create a pattern language. But more than 20 years later, the implementation of those ideas changed because language evolved, knowledge evolved. Now we know better. We have better ways of implementing solutions for the same problem. So that's what we're going to discuss today. And to propose the new implementations for the new version of old legacy design patterns, we're going to follow some guiding principles. So the first, from the original book, is still true, favor composition over inheritance. So we're going to apply it on all the implementations that we have today. Second principle, favor smaller interfaces, which some of you might recognize as the interface segregation principle from a book you might have read already. So favor smaller interfaces, and last but not least, favor existing interfaces. This principle I took from the Effective Java book. And why is that? We're going to show some code samples later. But why should we favor existing interfaces instead of creating new ones? Because remember, pattern language. With Java 8, we introduced, I believe, like 40 or 40 plus new interfaces that we can use as lambdas. We can use as functional interfaces. So almost 10 years later, I think most of us know what a predicate does. Most of us know what a function does. Most of us knows what a consumer does. So every time you create a new name in your code that has exactly the same behavior as an existing interface, you're creating what? More surface for more code that your developers need to read to be able to understand what your system is doing. So we're trying to reuse existing interfaces because we want to lower the threshold of knowledge that new developers need to understand to be able to maintain your code. That's why we're going to favor existing and smaller interfaces. And what are the ones that we're going to cover today? We're going to cover commands, observer, strategy, template methods, singleton, interpreter, chain of responsibility, visitor, and specification. These are the ones that I intend to cover. There are more, but for the purpose of this talk, I hope we'll be able to cover all of them in 45 minutes. And if not, all the code is available on my GitHub. I'll share the link later. First, command. Command, in the past, we used to create an public interface command, public void execute, and this would be an interface that we would be implementing when we wanted to get an action and transform that into a noun. Get an action and transform that into a class that we will be able to instantiate that. And of course, this is one looks like pretty obvious that we have an interface in the JDK that does the same, and we should be reusing public interface runnable, which only has a method void run, and that you can use, for example, when you're running your threads. Next one is observer. Actually, we still have a deprecated implementation of the observer pattern in the JDK, which doesn't have a guaranteed interaction order. So in 2023, we should try to do different. So we, instead of creating like public interface observer of type T, which has a type T event, we can use what? A similar interface, a similar function interface that we have in the JDK, which is this one, consumer of type T, which accepts a second type T. I'm not going to show the implementation because the implementation may vary depending on what you want. Do you want a thread-safe implementation? Do you want a guaranteed order implementation when you're interacting through the observables and through the observers? Well, it really depends up to you. But if you want to know the legacy implementation, of course, the source code is still available on the JDK. These are the simpler ones. And now let's move to other ones. Strategy. So let's move to the code. When you have this strategy one, I'm going to open here, and can you see the code in the back of the room? Kinda. I can try to increase the font size, but not much, because better? Okay, thank you. So, well, I have it open already, so instead of talking about the strategy, let's talk then first about the singleton. The legacy singleton one is this one. You have a private static final field instance, you can instantiate it right away, you can do a lazy loading, then you return the instance from here. You have a series of problems. For example, if you use serialization, this does not guarantee a single instance in your code, and the 2023 version of this, instead, when you want to create a singleton, well, you don't. You just declare an enum, and you type an instance. You have your modern version of what is a singleton. Most of us are using dependency injection frameworks that would guarantee this for us, but if you want your code to create a singleton, just use this one, and of course, this one I took from Effectively Java. If you want to move it forward, then let's pick the legacy strategy. In the legacy strategy implementation, what would you do here? You would create an interface with the method that does what you want to do. And usually the method that you want is receives something and returns another thing from another type. Well, luckily we have a function interface in Java 8+ that does exactly the same, which is function. Function receives one type and returns another one. It gets one parameter and transforms that to another type. So the legacy implementation would require you to create an interface. Here what I chose. Well, I chose to create an add to Google Wallet strategy, and I have two different implementations. I have a complete JOT, because Google Wallet links can be a complete JOT or can be a pre-created one. and then they differ from the implementation, but the interface is the same. So I would need to create two concrete classes, and both would need to implement the same interface, and I would be able to vary the strategy that I have here at runtime. I would, for example, create a class that will set the strategy as a parameter, and depending on what I wanted to achieve, I would do this. I would create an instance of the strategy implementation that I wanted, and I would set that as a parameter. That's what we used to do in the past. Well, the modern version is that I don't need to create a new interface anymore. I can reuse the existing ones that I have in the JDK. So here, my endpoint, instead of creating a new set strategy with a new interface, I just use the one that is already exists in the JDK, a function that receives a pass information and returns a string. And I say set function, and you can see that the behavior here didn't change. And when I want to set the implementation, I can do this. I can do endpoints. Endpoint, set function. Well, I receive pass information, and I want to do something with that. Well, let's try to simplify that. I want to say do something. Okay, and actually I need to return a string. Do something. That's implementation. And if your code grows, it becomes very big, which doesn't work as a one-liner. You can get this particular code, you create a class. For example, here I can have all the implementations for this particular strategy as different methods in my code. I can create a static methods, the complete jot. I type like multiple lines of code in these static methods, and I use a method reference here. Instead of just creating a lambda, I can create here the name of the class, add to Google Wallet link, complete. Okay, this is a static one, and just in case you don't want it to be static because you have other dependencies in your class, you can also use an instance method reference. Suppose that you're getting your class from a dependency injection framework. Well, you're getting that particular instance. In this case, because I don't have one, I'm going to instantiate a new one and say, well, use the implementation from this particular instance that I just received. And this object here, of course, you can receive it from anywhere. It means that I want to use this method from this particular instance, and this one, I'm using this method because it is a static one, right? So this is the modern way of implementing a legacy, actually a revisited version of the strategy pattern. If we learn how to use strategy, then another one is very simple to do, template methods. We used template methods a lot 20 years ago. The modern version, the revisited version of template methods is do not create template methods. And how can we do that? So if we do here, if I find here my legacy code, for example, I have this code, and it happens a lot when we're doing development. You have a piece of code. It's always the same in the beginning. It's always the same here in the end. For example, I created a Google Wallet Pass Creator. You have to first authenticate, and then the last step, you have to sign the token that was created. And here, you have multiple different things that you can do in between, but the first and the last steps are always the same. So I have one method here, I have another method here, and I have the piece that varies in these methods. And of course, this method is an abstract method because I have an abstract class. I just created an abstract method implementation. It's a template method. So the concrete classes, like I can create, for example, a loyalty class or an event ticket, and I have here the implementation. So all steps are the same. The only thing that changes is this particular method. I have two different implementations here, and I will want to run this code. Well, here I'm getting an instance that you would use, for example, if you have a dependency injection framework, you would be using the abstract class, and I would return, well, the implementation that I want. Well, now I want to create event tickets, or else I want to create loyalty cards. You return the implementation that you want. So that's how you increase the use and reduce duplication, use template methods. The revisited version of this implementation is to not create abstract classes, to not create template methods anymore. Instead, you replace template methods with strategy. So what do? You still have the thing that goes first. you still have the thing that goes last. But instead of creating an abstract method, you just create what? You just create here a function. So you create a function as a field of your class, and either you pass that as a setter or you pass that in the constructor of your class here. So here I'm getting a strategy as a constructor parameter, and I'm going to do the same thing as before. So instead of returning like a concrete implementation, like event ticket implementation or loyalty class implementation, I can use the Google Wallet pass creator because now it's a concrete class, not an abstract class anymore. And I can pass the implementation here. So here I'm receiving a pass information, and I need to return a map. So let's return a map of, well, 2 strings, a loyalty. Okay, loyalty. So that's how you do. You replace a template method with a strategy. And just like we did in the last example, if it doesn't fit in one-liner, you just use a method reference. So that's how you do template methods. What is the next one? Singleton. I've just shown because it was already on my screen. Next one, interpreter. Interpreter, this is a rare one, I'll admit, because most of us are not creating languages that need to be parsed on the CLI, but sometimes it happens. So, and because it's interesting to show as well, let's show the interpreter. The interpreter legacy implementation is this one. So basically you have a language, and I'm going to use the reverse Polish notation syntax, which I have like here 5, 7 plus, then 10, 5 minus, so 5 plus 7, 12, 10, 5 minus 5, and then I have 12 minus 5 should be 7, then result. So if I run this code, you should be returning 7. So what it does is look at this code, and why are we doing this? Because this syntax is very easy to parse with a stack. I'm going to split all the elements here in the string, and I'm going to get here the operation from the string. If the operation is null, I'm just going to pop the parameters that I have and apply the operation, or else I got a number, and I'm going to put that in the stack. This is if you read the book, you see how it is implemented, but the important part is that it's not it's kind of a modern version, because if you read Effective Java, the second edition, you already learned how to do this with enums. So enums are full-featured classes. So instead of having to create a class called add operation that extends or implements an interface, I'm creating here, I know what kinds of operation my system can do. So I created an enum. In here, I create an abstract method called apply. And I'm implementing this method in each one of my enum instances. So the add one is doing x plus y, and the subtract one is returning x minus y. And here I created a map of all the possible operations that I have. I also have a string value field. And when I implement this method from string, I'm just returning, you get plus. Well, I'm returning the add instance. If I receive a minus, I'm returning the subtract instance. And if I'm receiving something else, it's going to return null. This is the legacy implementation. This is something that was possible, I don't know, maybe 15 years ago. What is the revisited version of the interpreter pattern? Okay. And here, what did I change? Well, I'm applying the principle for strategy. You notice here that in the legacy version, well, you're just varying the operation. Well, it looks like we could replace this abstract method with what? With a strategy implementation. So that's the first thing that we did here. Instead of, I created here an enum constructor, and I'm receiving the binary operator as a parameter. So I receive 2 int and return an int. So I have add here, and I have subtract. Same implementation is doing the same thing, but now using the strategy pattern. And instead of returning just the operation, well, here I have a method that can return something or can return null. Well, luckily, we can use the optional class from the JDK to return an option of nullable here, which will allow us to use a simpler syntax. So once I have the string, the first thing that I need to do here is operation from string s. I got an optional. Well, the optional can be present or can be absent. And it reflects the two operations that I need to do here. Because if it's present, I do this. If it's absent, I do that. So what can we do here? I can do option from operation, and I can do an if present or else, because then I can use what? I can use the two parameters. First is the consumer of the operation. So I do have the operation. So if I found the operation, then I want to do operation.evaluate, and I get the first element of the stack and the second one. Okay? Stack.pop. And the second one, comma, I have a consumer, which is, actually, it's an empty action because I don't have it. So it means that I'm going to receive what? It's not an operation, so I can do stack.push integer.parseInt the string that I just received. Okay? And if I did everything correctly, I can just run this method, and we should return 7 as well. And just in case it doesn't, of course, it's live code. You can always go to GitHub. This implementation works. 7. Okay, I'm not lying. I'm just very bad in doing live implementations, apparently. Okay, now I know. Oh, stack.push. Yeah, I missed this one. So let's move forward. Interpreter, we learned how to do that. Chain of responsibility. This one, probably you needed to do this one in your code, but you didn't know how to do, and you didn't use a design pattern. So this one is interesting. Chain of responsibility, let's try to find a legacy one. How would you use this one? Look at this particular code. It doesn't look like that, but it is a chain of responsibility, because I have a user profile. And my user profile has 3 properties. It has Google Wallet Pass, allows email, allows SMS. So the user is configuring the way that he or she wants to be notified. And of course, I have different implementations that can update a Wallet Pass, send an email, or send an SMS. So it varies by user profile. And I have to implement that. Well, and you only want to send one type of notification. So if the user has a Wallet Pass, he or she was notified, I don't need to run the other implementations. So you only run the first one that applies. To do a chain, you need to create what? You need to create this interface, user notifier. You have a notify method, and you have the set next to notifier, which is the next chain, next link in the chain. And then you create an abstract one, where you just set the next notifier, and for each one of those implementations, you're going to do this. The notify, you can go look at the book, you have to do this. Well, the profile has the Google Wallet Pass enabled, then you send a pass update. If not, if you have a next link in the chain, you call the next one. Okay, so you're chaining the method invocations in each one of the links. I have an email notifier. Well, if the profile allows emails, well, I'm going to send, or else I'm send the next one. So that's what you do. The problem with this chain of responsibility implementation is that, first, it's a lot of repetition. You have here, this piece of code is always the same. And my method notify actually is doing 2 different things in the same implementation. First, is checking if this link in the chain applies to the parameter. Do I need to run, or else call the next one? And the second is the implementation by itself. So I have 2 responsibilities on the same methods. How can we do better in 2023? Well, let's try to re-implement that. You might have notes here in the legacy implementation. First piece returns a Boolean. Does it apply here? Well, what is the function interface of the JDK that does the exact same thing? Predicate. Receives a parameter and returns true or false. So this one is a predicate. And here, I have the actual implementation. You get the user profile that you just received here, and you do something with that. That's a consumer that receives something and does something with that. So how are we going to implement it? There are two different ways for us to do that. First is to create a record with two parameters. First is the predicate that tests the condition, and the second is the consumer that performs the actual implementation. So when you're instantiating a user notifier, you can apply lambdas to both parameters. This is one possibility. I'm still not certain which one is better. I think it's a matter of taste as of now. The second possible solution is to create concrete implementations and implement both consumer and predicate interfaces. So here now you have two separate methods with separate responsibilities. You have accept that tests, that performs the actual code, and the test that determines if your code should be applied to this particular parameter. Okay, so I have Google Wallet, Pass Update Notifier, email, and SMS. And now the chain implementation is not inside the links of the chain anymore. The chain implementation is here in your code. And actually your code becomes much more flexible because if you want to change the order of the chain, you can do that so easily here just by chaining a line. So what we need to do? We need to create a stream. And let's see. The first one is going to be the Google Wallet Pass Update Notifier, and email notifier, and SMS notifier. Okay? I created the stream. And then for each one of them, well, first I need to filter because only one of them needs to be true. How do I filter that? Well, I have here the notifier. And to do that, I can test the user profile that I just did. And here, IntelliJ added the cast that is not required. So I test if it's going to be applied to the parameter. And, well, I only need it to be applied to the first one. So I do a find first. Find first. And if I found any of them, if present, I can do, well, have the notifier is going to accept the user profile. Okay? This is the revisited implementation of the chain of responsibility. It's much easier for you to read what's happening. The implementation here is much clearer. You won't be able to make a mistake. Well, I forgot to call the next link in the chain. No, you can't do that because the interaction of the chain is here. And if somebody decides, well, the priority should be the email notification, well, you just go here, move up, and it's automatically updated. So this is the modern version of the chain of responsibility. And I know that some of you, I know that I did myself this code in production. I didn't know that I needed a chain, but with a chain, the code would be much simpler. And the revisited version of the chain of responsibility is this one. Cool? Visitor. So visitor is, I think, is one of the least used design patterns of the book. It's the most complicated one to implement and the hardest one to read when you have the code. Visitor is the design pattern that when you use in your code, you feel smart. Okay? And you want to brag about it. I know because I did it myself. I read the book and said, oh, this is amazing. Next day, I was trying to find a problem to apply the code, which is a silly way to code. I did it. I arrived very early in the office. I implemented the code. I committed the code. It was still Subversion at the time. And when my colleagues, they got the updated version, they were like, what the heck is that? Okay? And I was, no, this is a visitor. Oh, you don't know what is a visitor? Well, a visitor does this. Yeah? And of course, if you look at the code, it's super hard to know what it's doing. But actually, the visitor fits a very nice solution to a problem. When you need to vary the implementation based on a type, the description of the problem is that solution, well, you need a strategy. The problem appears when, well, I have this problem, and it needs to be solved with a strategy. I have this other problem in other part of my system that also needs a strategy. And both operations are being applied on the same type. Suddenly, if you're using the classic strategy implementation, you're going to have multiple methods in your hierarchy. Each one of them is going to do a different thing. And even worse, you have your class here, for example, usually it varies by a type on your domain model. Right? And you have a strategy here. You implemented the strategy here, but the code that is using the strategy is in another part of your system. Again, you need a strategy. You're implementing the strategy here in the domain model, but the part of your system that needs a strategy is over there. The code is better, is more readable. You have more cohesion. You have less coupling. When the code that you're using, the code that you're writing is closer to where it's being used. Okay? So if you write the code here in this package and you use it here, you have a low cohesion. So it's better if you write all the code that you need here in the same package close to each other. So that's a problem when you need multiple strategies based on the same hierarchy of types. When you do that, that's the problem that the visitor solves. You can move the strategy implementation. You can move the code, the implementation that varies by type from the hierarchy to the part of your system that is consuming the code. Okay? So I had to explain all of that to explain to you what is the problem that this visitor is trying to solve. And the legacy implementation of the visitor, if I can find it here, visitor legacy. Legacy is this one. I have a hierarchy, like a pass, can be a loyalty pass, can be an event ticket, and I want to implement the legacy here. So I have a hierarchy, and if I want to implement a visitor, I'm going to create a method called accept, an abstract method. I'm going to implement this in each one of my concrete classes. And the implementation is the same for each one of them. So it's basically copy-pasting, which is a bad thing, you might have realized. So it's the best, you're copy-pasting, but you're not calling the same methods. Because you have to call return visitor.visit this. And this instance varies for each type. So this here is a loyalty card. And this here is an event ticket. So when you implement your visitor, you need to create a method for each one of your implementations. And when you want to call it, well, you create a visitor, you get your card, and instead of calling the strategy, for example, the strategy would say, do something. This would be as the strategy implementation. But because you don't want the implementation to be on the other module of the system, you create a visitor because the code remains here. And then you create a visitor. Well, if it's a loyalty card, do this. If it's an event ticket, do that. And the beauty of the visitor is that it's type safe. And instead of returning if instance of something, which could technically achieve the same thing, the beauty of the visitor is that if sometime, like 6 months from now, somebody decides to create a new class. I'm going to create a generic pass, extends the same class, and I'm going to implement the method, return visitor, visit this. They decide to implement it, and the code doesn't compile anymore because, well, you created a new type, you have to update all the visitors in your system. You might think that it's a bad thing, but actually, your code won't compile if the developer doesn't fix it in every single part of your system that is calling the visitor. So this is a benefit of the visitor. It's type safe. If it compiles, it's going to work because the developer needs to implement all the use cases. So we're going to add this method here to the visitor. And now that I added there, well, it doesn't compile in the implementation. You have to implement this one. And now the code is compiling. So the visitor is very hard to to code, is even worse to read, but it fits beautifully if you have this particular problem. What is the revisited version of the visitor? Well, now you have a class, you have the same hierarchy, but instead of having to create a visitor, you can do things like this. I received a pass, and now with Java 20 Plus, I can switch on the pass type because we have pattern matching. And when I do, I can say, well, just in case it's a loyalty, I can return 5. And in case it's an event ticket, I can return 10. Actually, I don't need return. I just can just... No. What am I doing wrong? Oh, yeah. So nice when you have smart people watching your code. And still complaining. And why is that? Because you didn't exhaust all the possibilities, right? So you will need to do that. What? Default. Default return 1. Or even better, you would like throw an exception. Okay? But the problem with throwing an exception is that it's a runtime error. You need to run the code, and of course you're coding here, and the exception is only going to blow like 6 months from now. You want it to be type safe. And luckily for us, if you're using Java 20, you can do now what? A sealed class. And if you're doing a sealed class, you can do a permit, like loyalty, and event ticket. And this ones needs to be no. Final class. Final class. Now it's working, and you can even remove the default one because it's exhaustive. And if a developer decides to create another final class, generic pass extends Google Wallet pass, well, he or she needs to change here, and your code won't compile again. You need to fix it. Without the default in this case is a bad practice. If you need to add one, generic pass P is going to be 20. Okay? And with Java 20, you have even the benefit of be able to switch here, not only based on the type, but also based on the state of the parameter that you're receiving. So you have loyalty here. Suppose that you have your public int size. You have a parameter. You could do this. So case loyalty, when L.size greater than 10, return a 5. Well, when it's greater than 3, return a 3. And when it's just loyalty, you return a 5. So it's an enhanced visitor pattern. So now you're solving the same problem. You have operations that varies by type, and you don't want to implement that in the type hierarchy. You want to implement this close to where you're using. You don't need a visitor anymore. You can use the enhanced pattern matching here on the switches. And you can have the added benefit of, instead of having to create an if inside your visitor implementation, you can use simply here the when, and you can match also based on the state of the parameter that you're receiving. Cool? This is the revisited version of the visitor pattern. And last but not least, this one is from the domain-driven design book, specification. So I'm going to show you a super simplified version of the specification. And the legacy one is this one. So 10 years ago, 15 years ago almost, to be able to create a specification, and what is the problem that specification solves? Well, sometimes you want to create queries in your system or conditions in your system, and you want to do that in a readable way, okay? And also you want to compose those particular queries or conditions. Suppose that you wanted to express in a simpler way some simple conditions, and you want to translate something that match this and match that, or match with something else, and you want to translate that to SQL, or you want to translate that to any other query language that you have in your system. You could do that with a specification. Or you can just use the specification to create more meaningful queries and conditions in your system. So I would integrate here specification, I would implement an AND, an OR, or a NOT, and I would have to implement this. An AND specification, well, return this and that, and the other one, or, I return an OR, a NOT, I return a NOT here. So a very simple implementation. And if I wanted to use that in my system, suppose that I wanted to verify a credit card number. Well, I could express this in a very complicated way. I could create a regular expression today, and tomorrow I would have no idea what it did mean to me. Or I could create something that is readable. I could say, well, is the credit card number the right length? I can say, well, it's the right length. Is the string equals to 16, the length equals to 16? Is it just numeric? And this specification, if it matches only digits. And you could be composing these conditions over and over until I create a specification like this one. Specification, potential credit card number is the right length and is numeric. And of course, there are other validations, but we'll just lead and. So if a new developer joins your team and wants to know, what is this condition? Well, it's written in plain English here, or French. What does it mean? So you don't have to figure out what does the code do, what are these magic numbers. No, you have written here. You don't need even to comment your code if you coded it properly. Okay, so this is the legacy, but luckily, if we're using here, oops, I'm going to just show to you. Here, in 2023, we don't need to implement a specification anymore because luckily in the JDK, we have the predicate function interface. So now it's just a matter of, instead of creating our own specification classes, we can use the predicate ones. Predicates, right length, predicate is numeric, and you move forward. Exception to this particular example. This works if you just want to make your code more readable. If you really want to translate your specifications into other types of query languages, then you need to implement your concrete classes here. Okay? It's not enough to just be predicates. And once you do implement that, you also have two different ways, just like we did here with the chain of responsibility. You can create a record with your two conditions, your predicate and your consumer, or you can create a type hierarchy which implements both interfaces, predicate and consumer. It's up to you to decide which is the syntax that you prefer. Okay? And this is the last one that I wanted to share with you. This is probably the slide you want to take a picture. You might want to take a picture of me as well and post on Twitter. GitHub, YANAGA, revisiting design patterns. I'm constantly updating as soon as I get more ideas about different implementations of the design patterns. I'm trying to keep this one updated. I also would like to give a shout out to, after I started the research and was creating the code for this presentation, I found a talk from Mario Fusco about 5 years ago, talking about different modern implementations of design patterns. And I love to see how some of the ideas that we have are similar and some of the ideas we have are different. This is the beauty of having code. And I'll leave it up to you to choose which is the best implementation. Or maybe I'll leave it up to you to create different implementations and submit a pull request. Okay? So thank you so much. And thanks for attending my talk. And I don't know if we have time for questions. 1 minute. We have time for one question. No? You can ask in French. I don't guarantee I understand, but which might be a good thing. No? So, thank you so much. Last request, I would love to be able to take a selfie with you. Yeah. So I think it's the first one after 4 years. So say hi. Thank you again. Merci beaucoup.